As you heard earlier today, the lotus leaf is what has been used as the model for this type of technology. And what is very specific with the lotus leaf is that the topography of the surface is giving the surface its properties. It actually encapsulates air under the water, and that is one of the secrets. Here are pictures from the research done together with our Woodhead members. The picture at the left is a magnification 65,000 times of the topography of the superhydrophobic surface that we have done. And you can see it has similarities to the lotus leaf, that it has the structure in two different dimensions, so to say. I'm not sure if dimensions is the right word, but you can see the larger wavy structure at the bottom and then the flaky structure at the top. And this is very good to achieve a superhydrophobic surface. And to the right, there is a drop on the waxy superhydrophobic surface, and that is something you can see in real life outside later today. As you can imagine, there are a lot of different applications that might be that the superhydrophobic surfaces can be used for. The picture at the left is actually a picture of the building we are in right now, the Alba building. It has a lot of windows, which is very nice. It's very beautiful, the light inside is great, but someone has to clean the windows. By using superhydrophobic coating of the windows, you can get self-cleaning windows. And that is what the middle picture is supposed to show you, that the superhydrophobic drops that rolls off the surface, they actually take dust particles away from the surface, which is great. The bottom picture is a textile with water on. What you can do is you can actually treat textile the same way as you treat cellulose, because cotton is cellulose as well. And you can sort of get all the different surfaces you want superhydrophobic by starting looking at the lotus leaf. The technology we have developed, you can use wood, textile, metal, glass, plastic, whatever you want. And what is very good with this new method is that it's an environmentally friendly production method. Superhydrophobic surfaces has been made for a long time. Most of them are using either toxic coupling agents or fluorinated material. And as I mentioned, a lot of different substrates can be used for this method, and it's also scalable to be able to take to production. And then I have a few slides on magnetic cellulose. It's actually taking cellulose and combining with magnetic nanoparticles. It's a very valuable combination because you can get the advantages of both using cellulose, which is a great material, as you have heard a lot about today, as well as the magnetic properties that are desired in some applications. So here's a picture. To the left, you can see a cellulose backbone. It works as a scaffold where we have precipitated magnetic nanoparticles, and they remain nicely spread on the backbone. And to the right, there is a picture of the material we have made in the lab. We also show that one outside if you want to feel it. It's very light, it's lightweight, which is as cellulose, so the properties are great, but still you have improved or changed the properties of cellulose. Potential applications for this area include filtration and separation, biomedicine applications, information technology, and microwave absorbers. But I believe there are many more applications to come. This one, I heard you all sort of gasped when you saw Vincent's picture, which was almost the same like this one, going back to chemistry. We also have a platform that we called modified siloglucan. It is a great technology. It's very versatile. You can actually incorporate a multitude of different molecules to hemicellulose, which is a natural product which absorbs very tightly to cellulose. So any type of molecule you would like to add to cellulose, we can bind very tightly through this technology. And in the fiber modification area, we believe that there are a lot of things where our technologies can be used. For example, there are textiles, filtration, separation, composites, tissue hygiene, pulp and paper, of course, packaging, and biomedical applications. Our vision is to identify new use of renewable raw material and resources, and also to generate new high-value materials with environmentally sound profile, and also to increase the value of the products where our technologies are used. Are these the future products based on cellulose and forest materials? We never know. I believe that the toolbox suite we have right now, we can do a lot of these things. Thank you.
Thank you.
Thank you. Thank you, Sofia. Super hydrophobic. It almost sounds like the water is afraid of the surface.
Yes.